Hi everyone, my name's Connor McDonald. Welcome to the KISS series, the Keeping It Simple with SQL, focusing on partitioning. Each of these sessions are quick introductory sessions into the topic of partitioning, but unlike other tutorials, these are focused on developers. In the world of DevOps, developers now have to understand some of the physical design characteristics of partitioning. In this session, we're going to talk about an alternative kind of index called a local index, which only applies to partitioned tables. A quick recap on global indexes, as we discussed in the last video, that is an index that is a single structure that sits across all partitions in a table. It's a single segment that maps to multiple table segments. A local index is where we add the local clause at the end of the index definition. This creates a single logical index, but is actually comprised of multiple physical segments, each one equating to the table partition segment that maps underneath it. This means that the index comprises smaller chunks. It is multiple small segments, not a single large segment. Because each index partition is bound to the table partition, this is very useful for ILM and partition maintenance. If I go ahead and drop partition sales 2009, because the index is now segmented in the same way, only that partition disappears. The rest of the index segments stay valid, and my index is still valid for use for partitions 2010, 11, and 12. Here's that same example using our demo table. This time I've created the empno index as local. You can see each of the partitions is marked as usable. When I drop partition 4, there are no partitions marked as unusable. You can see the partition 4 for the index has disappeared. We have partitions 1, 2, 3, and then on to 5. This is awesome for information lifecycle management because when it comes to doing things like handling old data, we can now do things at a much more granular and partition level. I might choose to move a partition that's old to compress the data to make it smaller, and then rebuild the index on that. It has no implications on the other partitions. Compressing old data is very useful if that data has become predominantly read-only. Similarly, my old data might be expensive to store. I might want to move that data onto a slower but cheaper to run storage mechanism defined by a particular table space. If I then make that data read-only, that is a table space I no longer need to back up. So once again, now my backup windows shrink because I no longer need to back up that read-only data as long as it's backed up once. Similarly, I can combine that with a feature that came in 12.1 called deferred segments. I can take an index partition and make it unusable. Therefore, it disappears. It no longer consumes any space. I can no longer use the index to access data in 2009, but this may be a business policy. I want nice, fast access to my current data, say in 2012, but my older data back in 2009 is probably going to be just for analytics and trend analysis, and I'll be doing full scans anyway. As long as you're on 12C or higher, you can do this declaratively using the indexing off facility, which is part of partial indexing. In the same way as marking an index unusable, this will simply drop any relevant segment for an index that you turn off. You might even choose to do the opposite. You might choose to turn off indexing for the current data and leave indexing on the older data. That might seem a bit strange, but the reason you might choose to do that is one of the great facilities in the Oracle database is the in-memory option, which loads up data into a compressed column format for incredibly fast analytics. You might want to be doing real-time analytics on your most recent data, but you're prepared to use indexing and perhaps slower mechanisms for your older data. So you have plenty of flexibility as to how to manage index partitions when you're using local indexes. When it comes to handling incoming data, for example in a data warehouse, local indexes also have a lot of benefits here. If I need to add in the next year's worth of data, I can create a table outside of the partitioning system. This is a brand new standalone table. I can then index that. All of this can be done offline, and then we can use what's called an exchange facility, where we simply swap that table in to the partition table. Because we're not moving any data, we're just changing dictionary operations. That operation is virtually instantaneous. It's a very nice way of making data magically appear, so to speak, in your partitioned table. So far, we've seen how cool local indexes are. In the next video, we'll talk about why you still want to consider the differences between local and global indexes and why sometimes one is preferable over the other. Thanks very much for watching. You can get the entire video series on partitioning from the playlist, or just head over to asktom.oracle.com/partitioning for developers. And don't forget to keep it simply SQL. See you all soon.